Our project is called dog breed classification. Have you ever curious about a puppy you suddenly glance at the street or dying to know what kind of dog is in your friend's post? Our project would like to conduct research on how the deep neural network helps in dog breed classification. Our project should be able to make a prediction of the breed based on the specified dog image along with its confidence score. We will write our model into a much more user-friendly application to provide the prediction result and corresponding description of that breed. Our dataset was provided by Cargo Computation Dog Breed Identification, which is a subset of the Stanford dog dataset. This dataset includes 120 unique dog breeds with about 10,000 training dataset and 10,000 testing data. So due to the testing data don't have the labels, we randomly split the training dataset to be 9,000 images for training and 1,000 images for validations to improve our training process. And we randomly choose about 1,000 images in the testing dataset. Our project is based on PyTorch. We would like to explore more about the ResNet. Compared with the VGG network, the ResNet is a much deeper network. As can be proven mathematically, when one network gets more and more layers, the gradient of the parameters will vanish throughout the network, and small local visual cues could also get lost. The residue block can capture the feature maps from former layer. In addition to directly pass it to the exact next layer, it creates a residue skip connection and pass the features map to a few layers later. This move can greatly preserve the feature details as well as the gradient of each trainable layer, making it possible to train very deep network. Such a strategy has been proven to efficiently alleviate the gradient vanishing. So in our project, we tried with both ResNet 34 and ResNet 50. We finally choose ResNet 50 model based on its accuracy. Before training, we first do the data transform to avoid overfitting. We randomly crop the images based on the scale 0.9 to 1. We use the pre-trained image net width and the ResNet 34 for fine-tune our model. We compute our loss functions use the cross entropy.
So for our result, the accuracy on the training set using our model is about 99%, and then the accuracy on the validation set is about 80%. So on the cargo computation, you also using ResNet 50, it's about 75%. So in using our model, we improve the accuracy to about 80%. In our user interface, we have shown the predicted dog breed and also the confidence score with the predicted dog breed description. For the future improvement, we would like to add a dog detection feature to our model. So, for example, on the left of the image, we can see there's a dog object in the middle of the image, which is like really far away, so we couldn't see much more detail of the dog. So this is also for our model, which is hard to detect the feature of the dog, so it will make a harder prediction. So it will be harder for our model to predict the correct dog breed. So as the result, the dog breed that we predict on the left is wrong and with the lower confidence score. But after we add the dog detection feature on it, so we get a on the right, which is a higher resolution of the dog, which like more zoomed in. So we can see the more detailed feature of the dog. So as a result, our model did a better job on it. Have predict the correct dog breed with a higher confidence score. And then here's our demo. So our user interface is based on the PyQt5. So we decided to open our user interface using the terminal. So right now we are in the directory of our project, and then we run the IPython. And then we run our UI file. And then here's our user interface. So we first to want to load our ResNet 15 model. So we go to the directory of that model. And then we successfully loaded our model. Once our model is loaded, so we can test as many as images as we want. So the model is always there. So the next step is to randomly pick an image from the testing dataset. So we go to the testing image dataset and then randomly pick an image, and then we click predict. And then here's, as we can see, the result of our model predict of this image. So the dog breed, the confidence level is actually pretty high. And then the description of this dog breed.